See something.
Well, I noticed today that Bus Grease Monkey and Sean Himmelberger have taken on new hairdos. So if this is going to be the style, I shall join them. Okay? Mickey, Maggie, come here, puppies. Come here, puppies. Come on, say hi to Daddy. Come on, say hi to Dad. Okay, on with the show. WE0K here.
Okay, I hear you. Phil. WE0K, come on in and give us a check.
Okay, hello, Len. Good to have you back. We're sitting here contemplating trying another day, but if it's gonna work for us here today, we'll do it. I'm recording this session with my recently acquired lollipop, which I hold here in my formerly nicotine-stained fingers, and hope I'm sounding good down yonder there, Len. Now I got your call letter. I missed it. Oh yeah, Len, why can't I remember your call letter? W0LEN from WE0K.
Lost all of that, but I give you a signal did come way up in strength. But the weather station was very, very strong as well. So I didn't really copy much of anything that you said. Let me turn it back to you. I think the other station is gone now. WE0K, W0LEN.
Okay, Len, I'll take another shot at it. Hope you're doing well today. I hope it's bright and sunny and warm where you are. In Minneapolis, it's cloudy. It's 24 degrees, just a typical, plain, ordinary winter day. And so let's get back here and get Rich back in the conversation. I hear you quite well, Len. Anywhere from almost full quieting to almost totally disappeared. So the band is waving up and down today. WE0K, over to you, Rich.
Okay, fine business, Bill. Yeah, I am copying you fine, and I'm not hearing Lynn very well. You were about an S9 that time. Right now, I'm on the Drake TR7 and the Marathon AL811, pushing about 200 watts out, and I'm using the D104 microphone that's wired up for highest peaks. And I'm going to try another microphone here in a little bit, so I hope one of you are copying me pretty well. And I've got the recording equipment going. So back to you, Bill. WE0K, K0PIR.
This is a 6V6 acting as an oscillator. Many of you familiar with tubes think of this as a beam power tube in an audio amplifier circuit, and you're absolutely right. But somehow or other, the great designers of pre-World War II, when this transmitter was built, or designed rather, found a 6L6 will act as an oscillator, a 6V6. Then we moved to a 6L6. By the way, this transmitter had a 6V6 glass tube, and I found that it was radiating too much RF energy, and it was creating feedback way back in here where the transmitting tube is, where the power amp tube is. So by using a metal 6V6, eliminated that problem. Could also use a metal 6L6, but I choose this glass 6L6 because I can put a wire down through the top of the transmitter here and feed a frequency counter. So that's what I've done with that. Then we move on to a pair of 807s, which further amplify the RF signal. And remember I mentioned the 3 voltage regulators. This has its own power supply, and these 3 OD3 voltage regulators help keep a steady voltage here so the transmitter frequency doesn't drift a lot. So that's how we get the band that we want through these tuning units. Now we go over to the front of the system in preparation for tuning. So we start our process. By the way, be sure the filament voltage is 5.3. 5.3 to 5.5 is the recommended filament voltage. These tubes, many of them don't have cathodes. All the big power handling tubes do not have cathodes. They're filament emission triode tubes. So we set this voltage at 5. The tubes like the 6V6 and 6L6, those are the standard 6.3 volt filaments, and they're fed off of a separate transformer. So we begin our tuning by the doubler plate. We want to adjust the doubler plate current for minimum. So we turn on the exciter plate power switch, and this turns on the oscillator section of the transmitter. Now we begin by tuning the doubler plate current to minimum. That is the resonant position. And we use this doubler plate dial to do that, doubler plate knob. And we set for minimum. We want the plate to draw minimum current. That's when the circuit is tuned. So I'm turning this knob, and you can see there the doubler plate is at minimum. Now we switch to the internal amp grid, and we want our grid current as high as possible. So we go back to that same adjustment, that same knob, and we tune for maximum grid drive, maximum grid current. And if our system is working right, we're going to find that the maximum grid current and the minimum plate current are pretty much the same. If not, retune to dip the plate. Redip the plate, and you'll see they are the same. Okay, good. Now we're going to move up to the internal amp plate. And again, like we did with the doubler plate, we're going to adjust the internal amp plate current for minimum or resonance. So I'm turning this slowly, and there we are dipped. Now we go to the plate grid, the PA grid, and we want maximum grid current. And if you'll see, again, because these tuning unit components are all in good condition, we see that all of the settings are as they are supposed to be. So now we turn off the exciter plate power, and that completes tuning the transmitter to the frequency we're going to be operating on. The next thing we're going to do, why do amateurs always say we? The word is me, I. I will adjust this. And in order for me to get the plate current and to get the transmitter functional, I need to put the back cover back on. So I'm going to pause the video now and do that. I left out something I wanted to do. It probably there are people who are interested in what these tubes are. So I'm going to start with the lower deck. These are the main power rectifiers like I had explained earlier. These are 3B22s. 3B22. That is a mercury vapor rectifier. Then we go over to the modulation stages, and here we can see the rectifier for these two tubes. That's a 5Z3. And then these two tubes glowing are two A3s. Can you see them glowing? People like to see filament tubes. These are filament tubes. That's the rectifier tube. And here are the two 2A3 driver tubes. And those 2A3s are driving these 100 THs. And here's a rectifier circuit for those, another 5Z3. Then these drive the RF into the main power amplifier tube, which is a 250TH, another triode. And you can see the filaments. The filaments are glowing orange. The camera doesn't pick up that color very well, but the filaments are glowing orange. Now I'm going to make the final adjustment before we go on the air. I have the antenna now on a dummy load, which is one of these old oil cans. MFJ makes these dummy load oil cans that'll handle up to 500 watts. This transmitter in normal operating condition will put out 300 watts. So I'm ready for the final tuning. You'll notice that our excitation meter is set correctly, and you'll notice our filament voltage is my filament voltage. And so let us tune for 250 milliamps of plate current in the power amplifier tube. We have the exciter plate power turned on. We now have the plate power turned on. By the way, this high voltage protect. In case of a short or an overload, there's a relay that trips and we can reset it here. There's also an overload reset for the main power transformer. The modulator bias is adjusting the BC614 speech amplifier, to which is plugged in the microphone. This microphone I bought on eBay last week. I like these D104s. They really sound good. It's a crystal microphone. They really sound good AM transmissions. It's not that broadband broadcast quality with all that deep bass in it. It tends to amplify the high notes. The high part of our voice is what us old geezers need. We need to hear the highs. Okay, so those microphones are very good for that. All right, so we're ready for our last adjustment. I am going to turn on the plate power and quickly turn this dial and get this power down. See there? See that peak? We want to get it down. Don't leave this up here, because I'll show you what happens. This power amplifier tube, look at that. The plate is blistering hot. So get that current down to 250 milliamps quickly. Now it'll go low because we're on a dummy load. So I'm going to show you at 250 milliamps. this transmitter is putting out 300 watt AM carrier, okay, at the frequency that we chose. Now you'll see this power amplifier plate is still glowing, but it's at its normal red. Again, remember, these cameras do not do color when it's light emitting color. They'll show the color of an illuminated surface, but they will not show the color of a light. So here we are. We would actually be on the air right now, except I'm transmitting into a dummy load. And this is the power amplifier, and at 250 milliwatts, it's putting out 300 watts, and that glow of that tube is normal for that power output. And you'll see you can see the voltage regulators glowing. Almost looks like an eye tube, almost looks like a 65 eye tube, except the eye tubes are green. But there's 3 of those tubes, and they're regulating the B+ voltage to the oscillator circuits to keep the frequency stable. So that's what. Now I'm going to turn off the plate power and turn off the exciter power and open this lid and show you the final tank coil. These are plug-in coils for the bands that you're operating on. So remember the tuning unit. And so you plug a coil in like this for the band you're operating on. And here's one here I hold in my formerly nicotine-stained fingers. Aren't these beautiful little things? Aren't these pretty? I just think the engineers and developers from the late 30s were just so fantastically smart. They just really got the grace of God in them. Look at these beautiful little coils. These just plug right in, and here's that adjustable loop. Remember I told you about that adjustable loop? This is coming from the plate of that 200 TH into here, and it's coupling into this coil, which is going into the antenna circuit. And you adjust that plate current for 250 milliamps by changing the coupling like this. Isn't that clever? I just think this is so wonderful. So right now, since we're operating on 40 meters, all of us, I have the 40 meter coil in there. And when I put it back on the main antenna, I will reset the current for 250 milliamps. So that's it. Hope you enjoyed this part of it. Let me know what you think. WE0K, Bus Old Man, and Rich, by the way, will be doing the editing on this video to get out all the goofs and all the hisses and pops and fix it up right. Today, this 500 pounds of equipment and the 5,000-pound truck that carried it now is replaced with this 5-pound radio, this ICOM 706, which is 20 years old now. This is one of my favorite mobile rigs. And this radio will replace all of this transmitter. And this radio, of course, will sit right in the front seat of your car. Used to be able to mount them under the dashboard, but the way cars are built nowadays, we can't do that anymore. So that's what happens now. So I hope you enjoyed this. Doesn't have anything to do with buses unless you become a ham radio operator and mount one of these in your bus. And then you can have fun when you're on the road, when you're sitting around with nothing to do. Put your antenna up on the roof or outside and get on the air and find somebody to chat with. Just spontaneous conversations, nothing planned. Just get out and enjoy the world on ham radio. Some days the signals are good, some days are bad. So next time you're on your radio, put it near AM and tune it between stations and listen for out-of-town stations. And then at night, you will hear different out-of-town stations from far away. Like here in Minneapolis, WSM in Nashville at 650, or KMOX in St. Louis. Lots of stations come in from all over the country. It's better some nights than others. But anyway, have fun, enjoy. And now during this pandemic, play it safe, wear your mask, stay away from people, stay home unless you have to get out to go to the grocery store. Don't hoard toilet paper. It'll only make your house burn faster. Wear your mask, and I'll look forward to seeing you. Leave comments. Let me know what you think of these little side tracks I take from time to time. We'll get back to the bus stuff. Don't worry, got lots of good stuff planned. Adios. One more thing. Ham radio operations are not bus stuff, but I am a ham operator and I wanted to show you some of this stuff. It's a good way to stay inside and keep in touch with people. Ham radio operations are very valuable in communities where there is an emergency like a flood or a tornado. Our radio equipment can transmit at different distances, at different frequencies, under different circumstances, and we can communicate with government agencies who are trapped on one frequency with a very limited radio range. You may have heard about fire departments can't communicate with police departments, and hospitals can't communicate with this and that. They're trapped by the frequencies they're assigned and by the short distances of their radio communications. We ham operators can work with those people and transmit on frequencies that carry our signals long distances. We can relay information among agencies. So we're not strapped by that frequency assignment and distance restriction. Now, my dear friend Rich has done all this video processing from his house. He's put a lot of time and effort to it, and I really appreciate that. And I would like all of my friends to visit my friend Rich at his channel, Ham Radio with K0PIR. Please pay him a visit, and we appreciate your thumbs up, and we appreciate your comments, your stories, your curiosities, questions, whatever. And I'll get back with you with bus stuff come this spring. Got a lot of stuff we're going to do this spring. We're going to take the bus out for a drive. We're going to go downtown. We're going to do stuff within the limits of this COVID pandemic. So thanks again.